Welcome to Maths for All. I'm Aisling Flynn. This is the line 1.2 slope and midpoint. On the graph, plot the points A and B. So A is -3, -5, and we can label it here with the letter A. And B is 3, 7. We can label that with B. And now we're asked to join the points A and B to make the line segment AB. Okay, so it's called a line segment because without the start and the finish point, this line continues forever in both directions. So it's a piece of that continuous line from A to B, so it's called a segment. Now, to calculate the slope of this line, the slope of a line is how quickly it rises or falls. Now, to do this, we're going to do some counting. We're going to put our pencil on point A and count across a number of boxes. So you can go any number at all. I'm going to count from A here. 1, 2, 3 boxes, and I'm going to stop here. So I counted 3 boxes. Okay, and I'm going to fill in that value here. 3 boxes across. This is what we call the run. It's the horizontal distance we run across. Okay, and now we're going to see from here, we're going to count up, or sometimes you have to count down boxes until we hit the line AB. So I'm going to count up 1 box, 2 box, 3, 4, 5, 6 until I hit the red line. So I've counted 6 units up. Okay, so 6 units up. And this is called the rise. So we ran across and we rise up. This is the vertical distance. And we have values of 6 and 3. And now we're going to calculate the slope. So we're going to use the relationship between the run across and the rise up, rise over run, to calculate slope. Okay, so our slope is going to be rise was 6 over run, which was 3, and 6 divided by 3 is 2. So our line here, AB, has a slope of 2. Now what does that mean? It means for every box that you go across, so from A, if I go across 1 box, I rise up 2. Okay, so 1 is to 2. It was 3 boxes across, we go up 6. If we go 6 boxes across from A, we should go up 12. So 6 is to 12, and so on. Okay, so it tells us with every box across, how much does it go up. So every 1 box across, we go up 2 units. Okay, now we can do it using the formula also. I'll show you that quickly, but if you can count from the graph, rise over run is much quicker. So the formula uses the coordinates of the points. So if I jump up to the top of the slide here where we have A, that's going to be our first point, so we'll call it x1, y1. So x1 is -3, y1 is -5, and point B we'll call our second point, we'll call it x2, y2. If we fill those numbers in the formula here, we should get the same answer. So y2 was 7. Take away, says the formula, and y1 is -5. Okay, you're following? Underneath we have the x values. x2 was 3, formula says take away, and x1 was -3. Okay, now we know that when you take a negative it becomes a positive, so that becomes 7 plus 5 on the top line, and it becomes 3 plus 3 on the bottom line. And what do we get? We get 12 divided by 6, which is of course 2 as well. So you have choice. You can use rise over run or the formula, but rise over run, if you have the graph drawn, is by far the easiest way. The slope formula, the one y2 minus y1 over x2 minus x1, that is in your formula books if you need it, okay, on the coordinate geometry pages. Now, so this time we are going to plot the points C and D. So point C is -2, -3, that's down there. Point D is 3, 9. That's up there. And we're going to join them up to make the line segment CD. And firstly, we're asked to find the slope of CD. Okay, so let's have a go at that. Given what we looked at on the previous slide, we learned that slope equals rise over run. Okay, so I'm putting my pencil here on point C, and I'm going to count across a number of boxes. Actually, I'm going to go the whole way across until I'm right under D, and that is 1, 2, 3, 4, 5 units. And then I'm going to count straight up, so you'll always get kind of this right angle triangle, and count the units there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's 12 units up, and so the slope is rise, which is rise up 12, over run, which is run across 5, and you can leave your answer like this. Okay, that's perfectly usable for coordinate geometry. If you really wanted, you could change it to decimals, 2.4 if you want to compare it to the line on the previous page. So what does it mean? It means for every box you go across here from C, you rise up 2.4, nearly 2.5 boxes going up. So this line is rising quicker than the line on the previous slide. Now we're asked to find next the midpoint of the line segment CD. It's the point that is halfway between points C and D. Okay, now often we can see that just by looking. Okay, but we want to calculate it also. Okay, so to find the midpoint of CD, we look at the horizontal distance between C and D. We've already done that while we did the slope. We see that there's 5 units across, brings you from C to D. Okay, so from C has x value minus 2. Okay, so from minus 2 to 3, which is for D. Okay, and there's 5 units across. What is halfway between these two values on the x-axis? So halfway would be 2.5 and 2.5 boxes, and it would bring me to half of 5. Okay, it brings me here to halfway between 0 and 1, so I would say it's 0.5 or a half. Okay, and this is the x value of the midpoint. Look at the vertical distance between points C and D. Okay, so we saw already that the rise up from C to D is 12. So we're going from, on the y-axis, C is at minus 3 and D is at plus 9. So in total we saw that was 12 units. So what's halfway along this line from minus 3 up to plus 9? Well, it's 6 boxes up or 6 boxes down. So we divide that 12 into 2 halves. So 1, 2, 3, 4, 5, 6. So here is halfway, you get 6 and 6. And here we're at y is 3. Okay. This is the y value of the midpoint. Okay, so where these two lines coincide, so halfway along the horizontal and halfway up the vertical, we get the midpoint. Okay, right here. Okay, loads of scribbles there now, it's not so clear. Okay, and you can see quite clearly that it is halfway between C and D along the sloped line. And so our midpoint, we'll say, is a half, 3. Okay, so we do have a formula we can use as well. It's available in the formula book, and it's x1 plus x2 over 2. Now what's that? That's just getting the average of two x values. It gets you the middle. And the same for the y value, y1 plus y2 over 2. So we'll try the formula one time to show you. So again, we have 2 points. C is the first one, so look up to the top of the slide. We'll call that x1, y1. Okay, that's our first point, and D is the second point. We'll call those coordinates x2 and y2. Okay, let's substitute into the formula. X1 is minus 2 plus x2 is 3. Okay, and we have to divide that by 2. That'll give us an x value, comma, so these are going to be coordinates, an x comma y. Y1, if you look up, is minus 3, and y2 is plus 9, and we have to divide those by 2. So for the x values, minus 2 plus 3 gives me plus 1, and that needs to be divided by 2. And then we have minus 3 plus 9 gives me plus 6, and that needs to be divided by 2. So we'll leave the x value as a half, and 6 divided by 2 is 3, so we get the same answer. So when you have the graph drawn, it is definitely easier just to do it by counting. Halfway along the horizontal direction and halfway on the vertical. If you have the coordinates, you can use the formula. So now we'll try this one for some extra practice at that. On the graph, plot the points A and B. So A is minus 3, 5. So minus 3 in the x direction, back 3, up 5. So that's my A. Okay. And B is 1 minus 3. So write 1 down 3. Here is B. And we're going to join them up to make a line segment. Okay, you'll do better with your ruler, of course. Okay. And we have to find the slope firstly. So let's on the right hand side here we see slope equals rise over run. Okay, I'm going to use that method, the graph method. So I'm starting at A, I'm going to run across. Okay, it looks a little bit different from before because A is higher than B. So I'm going to run across till I'm directly above B and count the boxes 1, 2, 3, 4. So that's my run, and it's 4. And this time we have to go down, okay, to get to B. So how far do I have to go down? I have to go down 5 to get to the x-axis and another 3. So that's down 8. So our rise is down 8, and to show down we use the minus sign, is minus 8. Okay, so when I'm doing an exam, I'd always write down slope equals rise over run. I'd put my numbers in next, so minus 8 for the rise and 4 for the run, and minus 8 divided by 4 is minus 2. So what does the minus sign show us? It shows a negative slope. It shows that the line segment AB is falling or decreasing, okay, as you go from left to right. The second part of this question asks you to find the midpoint. Okay, so let's look at the horizontal distance first. Our run was 4, so what's half 4? It's 2, so count across 2 boxes. Okay, so our midpoint should be along here someplace. And our rise was 8 in total, so that's 4 and 4 divided in half. And then we should get our midpoint, which is right here. Okay, and our midpoint we can see has x value minus 1 and y value plus 1. So that's that done using the graph. So a note here on slope and parallel and perpendicular lines. So what does parallel mean? Parallel lines have the same slope. So here we have 2 parallel lines pictured. Okay, you can see that they're pointing in the same direction, they have the same slope, and they will never ever meet or cross. So parallel lines have the same slope. Okay, so let's say for example the line MN has slope equal to, and it will be negative because they're falling, let's say minus a quarter, well then OP will also have slope of minus a quarter. Okay, and we write line A is parallel to line B. So this symbol here, two lines like this, means parallel. Perpendicular lines meet at right angles or make an angle of 90 degrees. And that's what they look like. Okay, here you can see that one of the lines has a negative slope and the second line has a positive slope. Okay, and they meet such that they make 90 degrees in each of these corners, 90, 90, 90, 90. Okay, we write line A is perpendicular to line B, so this symbol here, like an upside down T, means perpendicular. We're going to relate the perpendicular slopes to each other in a minute. Okay, so given a slope of a line, to find the perpendicular slope, what we do is we turn the slope upside down and inside out, meaning we change the signs. So it's the exact opposite slope. Okay, some examples of perpendicular slopes are, so if the first line has a slope of 2 over 3. Okay, the second, so let's call this line A. The second slope will have, let's call it line B, will have slope of exactly the opposite. So if you started with a plus, now you have a minus, and we started with 2 over 3, now we turn it upside down, it's now 3 over 2. Okay, let's say that line C had slope of minus 4. Now that's a whole number, and if we wanted, we could write it as 4 divided by 1. Okay, it is negative, and a line that's perpendicular to it, line D, would have slope, instead of negative, you'd have positive, and instead of 4 over 1, you'd have 1 over 4. So that's why I call it upside down and inside out. So everything is different. Change the signs and turn it upside down. Now the test for perpendicular lines is if you take two slopes and multiply them by each other, you should get an answer of minus 1. So we've taken line C and D here as the examples. Minus 4 over 1 multiplied by 1 over 4, you get on the top line minus 4 by 1 is minus 4, and bottom by bottom 1 times 4 gives you 4, and minus 4 divided by 4 gives you minus 1. So you can say that line C is perpendicular to line D. Okay, so here we have a question around plotting points and measuring slopes. Okay, so A, B, C and D are 4 points. Show that the slope of AB is the same as the slope of CD. Okay, so let's plot them first. So A is 2, 4 and label, that's A. B is 6, 7, which is here. Okay, that's B. And I'm going to join them up. Okay, C is 10, 5 and D is 6, 2. That's D, and I'm going to join those up. Okay, and we're asked to show that the slope of AB is the same as the slope of CD. Now it certainly looks like it, doesn't it? They look to be pointing in the same direction, but let's do some measurement. Now the letter M is used for slope, so I'm just going to use that so you become familiar with it. So the slope is equal to rise over run. So let's work with AB. Let's count across some boxes until we're under, from A until we're directly under B, and that's 1, 2, 3, 4 boxes. Okay, so that's my run. And then let me rise up till I hit B. That's 3 boxes up, and that's my rise. So my slope is rise over run, that's 3 over 4. Okay, let's repeat that for line CD. Okay, now you can start at C or D, it doesn't matter. We usually work from left to right. So I'm starting at D this time. Run across until I'm directly under C. So that's, you can see the run is 4. Okay, and rise up till I hit C, that's 3 boxes. Okay, so the slope is equal to rise over run. The rise was shown to be 3 over 4. Okay, and then I can write therefore, that's the 3 dots, I can say that AB is parallel to CD because they have the same slope. Alright, here's another question. A, B, C and D are 4 points in the plane. Find the slope of AB first and then CD and verify, the word verify means show it is true, that AB is perpendicular to CD. So let's start with AB. So minus 1, 1 is A, so let's plot it first. So minus 1, 1, that's there, that's A. And 1, 3 is B, that's here. B, and we join them up. There's our line AB. Okay, so we're going to get the slope of AB, which is the rise over the run. Okay, so let's run across from A to directly under B, that's 2 boxes, and then let's rise up, and that's another 2 boxes. So my rise is 2 and my run is 2, so 2 divided by 2 is 1. That's my slope of AB, and that was part 1. Part 2 asked me to find the slope of CD. So C was 6, 2, which is here. And D is 4, 4. So that is here. Okay, D. And that's what that looks like. Okay, so to find the slope of CD, it's rise over run. Okay, I'm working from left to right, so I'll start with D. I'm going to run across to when I'm in line with C, that's 2 boxes across, that's my run. And I have to go down this time to C, that's minus 2, that's my rise. Okay, so rise, minus 2, run was 2. Minus 2 divided by 2 is minus 1, and that's the slope of CD. Okay, we're asked to verify that AB is perpendicular to CD, and the test for that is to multiply. So let's take the slope of AB, which is 1, multiplied by the slope of CD, which is minus 1, and the answer we get is minus 1, which is correct. Okay, we said if 2 slopes are perpendicular, when you multiply them you should get the answer minus 1. So we can say therefore AB is perpendicular to CD. Now kind of looks like it there. If we extended both lines, I think you'd find that yes, they do meet and cross at 90 degrees. Now, you try some questions on that with the quiz and the written exercises.